Okay, in this video tutorial, I will show you how IP version 6 works. Okay, IP version 6 uses 128 bits addresses, which approximately has about 3.4 multiplied by 10 to the 38 power addresses. Okay, this is theoretically speaking. In reality, practically speaking, the number will be less than that, as opposed to IP version 4, which uses 32-bit addresses and provide only 4.3 billion addresses. IP version 4 and IP version 6 are not designed to be interoperable. This is gonna complicating the transition from IP version 4 to IP version 6. Okay. IP version 6 is represented as an 8 groups of 4 hexadecimal digit or 16-bit. For example, 2001 colon 0 DB8. This one is called 4 hexadecimal digit or 16 bits. Okay. So in IP version 6 there are 8 of this. If you look at on my note on the top, an example of IP version 6 is 2233 dot colon 0000 colon 2222 colon 0011 colon 000 colon 0000 colon 0000 colon and 0000 slash 64. That means this is 64-bit on the network. Okay. Remember, IP version 6 is 128. So this network portion is 64-bit and the host is also 64 bits. Okay. So the first 3 octet, which is this, the first 3 octet is the ISP prefix, and the 4th octet is called subnet. So this IP version 6 is on the 11 subnet or 0011 subnet, and this, the last 4 octet, represent the identification of host ID. Okay, that's referred to the host ID. Alright, so coming back to my note here, how do you configure the hexadecimal number? Well, hexadecimal number is base 16, so they are up to E here, okay, up to F actually. So the only difference between decimal and hexadecimal is the number 10. Okay, in decimal it represents by 10, and in hexadecimal you start with an A. So 11 is B, 12 is C, 13 and D, and so on. So the binary number, for example, if you have 9, the binary number is 1, 1 and 1. So the binary number of 9 is 1001. In the hexadecimal is also the same as 9. The next one is 10. On the 10, the binary number is 1, 0, 1, which is from the 2 here. So 8 plus 2 is 10. So the binary number is 1010. The hexadecimal number is 8. Okay. The next one is 11. 11 decimal, the binary number is 1, which is from the 8 here, 1, 0, 1, which is 8 plus 2 is 10, and another 1, 1. So the binary number of 11 is 1011. The hexadecimal number is B. Okay, let me give you another one. 12. 12, the binary number is 11, which is 8 plus 4, 12, and 00. Right? The hexadecimal number is C. So this up to F, which is 15. 14 is E, and then 15 is F. Therefore, it is said that hexadecimal is the base 16. Okay. in these nodes, I get cut off. But when I attach this node in the Blackboard, you will find the full paper. Alright, so for example, if 2001, this is called 16-bit or 4 hexadecimal digit, colon 0DB8, this is called 16 bits, which is also 4 hexadecimal, so which is equal to 32-bit. This is 16-bit and this is 16-bit, so equal to 32-bit. Going back to the top, if you notice that I give you the long address of the IP version 4, right? This long form of IP version 6 can be abbreviated to a simple one. For example, 2233 colon 0 colon. What is 0 here? Well, notice that a quartet of 40 can be abbreviated as 0. Therefore, 2233 colon 0. Okay? So all 40, a quartet of 40 can be abbreviated just as 0. So 2233 colon 0 colon 222, which is the same, and then notice that here I'm going to be abbreviated also, colon 11. So 0011, leading 0 in a quartet can always be omitted. So 0011, the first two 0 can be omitted. Alright, and then you see colon colon. So all the last 4 quartet of 0, there are 4 zeros in the consecutive 4 zeros can be abbreviated as colon colon. Okay. So the short form of this 2233.00.222 until the end can be abbreviated as 2233 colon 0 colon 2222 colon 11 colon colon slash 64. That means you are on the 64 network. Later on in the next video, I'm going to show you how to configure IP version 6 in the Cisco router. For example, we have .11 subnet, .112 subnet, and .12 subnet. Okay, so I'm gonna explain to you in the next video. Thank you.